Hello everyone and welcome back to the course. In this lesson, we will take a look at code execution flow. We will learn about nodes that allow us to execute code based on specific conditions, restrict execution, or simply allow us to repeat a certain part of our code several times. All of this will give us the ability to control the order in which our code executes within our game. Let's get started. And now that we're back into Unreal, let's go ahead and remove these top nodes here from our previous example. Right click and search for sequence. Go ahead and select it. And this node does exactly what it says. It executes code in a sequence. So what we're going to do is recreate a previous example that we've used in the lesson before by first shuffling our array. So go ahead and connect the first pin to shuffle. And second, we want to simply display index 0. So here we are getting the results of index 0, and we simply use print string to see the results. And connect then 1 to print string. And if you double click on any of the execution wires, like so, you create what is called a reroute node. And this is a way of organizing the wires. So click and drag to organize the results, and then simply connect the event begin play to the sequence node. Let's go ahead and compile and go back to our level. Now click on simulate. And in this case, we get Cookie Games. Stop, simulate again. And in this case, we get Epic Games. Let's go ahead and stop and go back to our blueprint. As you can see, we are simply executing the shuffle first and then grabbing the first index and displaying it. Again, we can continue to add more and more pins to the node to execute code in a sequence. Now let's go ahead and remove all of the nodes from this example. And now right click and search for flip-flop. This node simply executes path A and B in an alternating manner. In other words, when you first call the node, it'll execute A, but when you call the node again, it'll execute B. And it'll simply alternate between A and B infinitely. So for this example, we'll do something quite simple. We'll simply grab our myArray variable and get the value of our first index. And in this case, we'll simply print the results. Now let's go ahead and copy those nodes, paste them at the bottom, and connect them to B. We'll use a reroute node here. This way we keep the code organized, but instead of printing the results of index 0, we'll change this to index 1. Now, we'll connect the event begin play to flip-flop, and we'll do another reroute node in between. Finally, we'll drag from the print string at the top all the way to the reroute node here. And we'll do these other two reroute nodes to keep the code organized. Basically, we'll call them the flip-flop node once. It'll execute path A, which will print the results of index 0. Then this node will go back and call the flip-flop node again, but this time flip-flop should now go through path B and then print the results of index 1. Let's go ahead and compile and go back to our map and click on simulate. As you can see, it printed index 0 and then index 1. Let's go ahead and stop and go back to our blueprint. This isn't the best example. Normally you would do this for more practical examples, such as a light switch would be a great example where the player would simply interact with a light switch and every time the player would interact, the light would either turn on or off. But for this lesson, we'll stick to the array example. For this next example, we have a node that guarantees that our code will be executed just once. So go ahead and right click and search for do once and select it. And for the example, we'll copy these nodes right here, and we can go ahead and delete all of the nodes connected to begin play. Now simply connect event tick to the print string here, and let's compile and go back to the map. If we click on simulate, you'll notice that we're simply printing index 0 indefinitely. Let's go ahead and stop and go back to our blueprint. But now, if we connect the do once node in between, this code will only be executed once. So let's test that out. Click compile, go back to our map, and click on simulate. As you can see, Koki Games only printed once. Let's go back. Very simple node, but very useful. This next example is very similar to do once, and the node is called do n. So go ahead and right click, search for do n, and in this case you'll have to scroll all the way down until you find it. So you can see it right here. Go ahead and select it, and we'll simply replace the do once node with the do n node. And as the node name implies, this will simply allow the execution of its code n number of times. So in this case, n0 means it will not be executed, but if we change this to 1, we are effectively creating a do once node. So let's try that out. Compile, go back to our level, and click simulate. As you can see, again, Koki Games only prints once. Stop. Let's go back to our blueprint. But obviously in this case, you can specify how many times you want this action to be executed until the node basically locks its execution path from executing again. So in this example, again, we'll just put 3, compile, go back to your map, and click simulate. And as expected, it prints Koki Games 3 times. Let's go back to our blueprint. This node is useful if you want to cap the amount of times an action is allowed to happen. And again, notice that we do have a reset pin here, so during gameplay you can go ahead and reset the counter and allow the node to execute again. So let's go ahead and remove these nodes. And the next node is perhaps the most common flow control technique in programming, and that is called the if statement. In Unreal, it is called the branch node. So go ahead and right click, search for branch, and select the node. This node has 2 output pins, a true and a false, and it'll execute based on a condition which happens to be a Boolean. And as we know, a Boolean can be true or false. So for our example, let's go ahead and drag our array and use the contain node. And in this case, let's go ahead and click on our array and copy the first one here, Koki Games, and paste it in here. Let's go ahead and connect it. And we'll simply use a print string to let us know if it found the item or if it did not find the item. So let's go ahead and add our print strings. And for this example, I'll simply add item found. Now go ahead and copy the same node and connect it to false, but this time add item not found. Go ahead and compile, go back to our map, and click on simulate. As you can see, it says item found. Let's go back to our blueprint, and let's simply add an additional character to Koki Games. Let's go ahead and compile, go back to our map, and click on simulate. As you can see, it said item not found. Let's go back to our blueprint. Very simple, node, but extremely useful. You'll find that we're going to be using this node extensively as we go along the course and continue to use more and more complex examples. Let's go ahead and remove the nodes. For these 3 examples, we will use what are called loops. A loop is a simple way of repeating an action a certain number of times. So the first thing we'll use is called a for each loop. So right click and search for each. Go ahead and select it. And you'll see that the node has an execution pin and a connection to an array. This node will simply execute for every single element in the array. So if we simply drag our array and connect it as so, you'll see that now we have a few things going on here. We have a loop body, we have an array element, and an array index. This node will execute its loop body for every single element in the array. In this case, we have 3 elements, index 0 through 2, so it'll execute 3 times, and every time it executes, it'll return the actual array element, which is a string, and the index starting from 0. When it completes all of this, it'll then execute the completed pin, as you can see here. So a simple example would be to print all of the elements of our array. And we can do that by simply using a print string, like so. As you can see, for every item, the loop body will execute a print string and will simply print the array element, as so. Let's go ahead and connect the begin play. And finally, let's do another print string at the end to make sure that the node completed. For this example, enter completed. Now let's go ahead and compile. Let's go back to our map and click on simulate. Notice that we have all of the array elements printed with completed at the end. Go ahead and stop. Let's go back to our blueprint. This is a very common example of how we can iterate or go through all of the elements of our array and perform a certain action. The next loop type is called a for loop. So go ahead and right click and search for loop. And here at the bottom, you'll see that we have 2, for loop and for loop with break. Go ahead and select the first one. And you'll notice that we have very similar output nodes here. We have a loop body, we have an index, and we have a completed. However, instead of taking in an array, it'll simply repeat an action between the first and the last index. So if we wanted to replicate this exact setup, we could do it with a for loop. We know by clicking on our array that we have 3 elements in our array. So if we go from 0 to 2, we'll go through all of the items in our array, and we can simply copy our array like so and use a get node, and then we can print this to the screen. This is an example we've done on our previous lesson, but now we're integrating that with a for loop. So if we connect this to the loop body, we will then print element 0 every time we iterate between the first and last index. But lastly, if we connect the index from the loop to the actual input pin of our get, we will now effectively print every single item in the array between index 0 and 2. And if we copy this node here and connect it to completed, you'll see that we have effectively done the exact same setup as above. So go ahead and connect begin play to our for loop like so. Compile, and now let's go back to our map. Click on simulate, and as you can see, we have the exact same setup. Go ahead and stop and go back to our blueprint. In this case, we matched it exactly to our array, but notice that you can obviously change the numbers here and do something to a subset of the array. For this next example, let's go ahead and remove all of the nodes that we have here. Right click and search for while loop. Go ahead and select it. And this loop will execute as long as the condition here is true. This loop is useful when we don't know exactly how many times we need to repeat an action. As long as this condition here is true, the loop body will be executed and the node will be called again. Notice that this means that if the condition never turns to false, the loop will continue to execute indefinitely. This is called an infinite loop, and it'll typically crash your program. Unreal is smart enough to detect an infinite loop and will simply stop execution. So we will try again on this example to recreate what we have done with the other two loops. But this will be a little bit more advanced because we need to now take care of the condition to make sure that we do not have an infinite loop. So the first thing we need to do is make sure that we print our elements to the screen as before. So go ahead and drag your array, select get, and let's use the get node here as before and use the print string. Let's go ahead and connect the loop body. And now we see that we are simply printing element of index 0 every single time the loop body executes. However, we want to make sure that we update the index value here so we can iterate through all the elements of our array. The easiest way to do this is to simply create a variable that will keep track of the index that we need to use here. So go ahead and right click and select promote to variable. And in this case, let's call this variable counter. Compile. And as you can see, we are now using the counter variable, which has 0 by default, to grab our element that we want to print on the screen. However, since we want to go down the array, element 0, index 1, index 2, etc., we need to make sure that we increase our counter every single time the loop body is called. So go ahead and select counter, copy it and paste it, and drag from counter and search for plus plus. This will give us a node that is called increment int, and as you can see, it simply adds 1 to the specified value and it then sets it. Go ahead and select it and connect it to print screen. So now every time the loop body is called, it'll print the element with the index based on our counter, and it'll simply increase our counter by 1. So counter will be 0, 1, 2, 3, etc. Now we need to deal with our condition to make sure we don't have an infinite loop. So let's go ahead and connect our node here and give ourselves a little bit of space for the condition. So let's think about this a little bit. We want the while loop to continue printing all our elements as long as we have enough elements in the array. So the first thing we'll remember is from our previous lesson, there is a way to get the number of items inside our array, and that is called the array length. So go ahead and select your array, copy and paste it, and drag and search for length. We have the length of our array, which we know is 3 by looking at the number of elements here, and now we want to make sure that the loop continues to run as long as our counter is less than the number of elements in our array. So grab the counter and copy it and drag from counter and simply search for less than. Select less and now simply connect the length to the other pin. Let's move the nodes here and connect the boolean to our condition. Now let's quickly analyze what we're doing here. When we first call the while loop, it'll analyze the condition here and it'll say, is the counter less than the length of our array? Our counter will be 0 and the length of our array is obviously 3. This will evaluate to true, which means that the loop body will execute. We'll print element 0 and it will increase our counter by 1. When the loop is called again, it'll once again evaluate our condition. This time counter is 1. Is 1 less than 3? And it'll execute again. Eventually our counter will increase to 3 In that case, when the loop is called, the condition will read is 3 less than 3, which will obviously result in false. And at that point, the loop will be completed. So let's go ahead and use a print string here as before and simply type complete. I'm going to zoom out a little bit so you can see the entire example. Go ahead and compile. And now let's go back to our level. Click on simulate and watch the results. Let's go ahead and stop and go back to our blueprint. As you can see, we have replicated the same example as before by using the while loop. Obviously, in an example like this, you would simply use the for each loop. That would be the easiest way of accomplishing our goal. But nonetheless, it's a good example to really understand how you would use the while loop. And always make sure that there is one way that the condition will eventually turn to false. Otherwise, you will get that infinite loop issue. So let's go ahead and remove all of the nodes here for our next example. And so far, we have iterated through the array one by one and done something specific, usually the exact same action for every element in the array. But what if we wanted to have different actions happen based on different elements of the array? That is when we use a switch statement. So let's go ahead and think about this for a second. Go ahead and drag your array to the event graph like so. And let's use the random node as before. And now we have a random element from the array. But let's say that we wanted to do different things based on the element that was selected. You can simply drag and search for switch. And you will find that we have switch on string. Go ahead and select that and connect it to begin play. The switch node will have different pins for the different values that can go inside the selection. Right now we simply have a default pin, but you can clearly see that we have an option to add additional pins. So go ahead and click add pin. And now you'll see that we have a new node called case_0. Obviously, this is just the default value. So if you go to the details panel, you can see that we basically have an array with a string here that we can change to match our selection. So if we click on our array here, we see that our first selection, index 0, is Koki Games. So if we go back to our switch on string node, we can simply enter the exact same here. And now you can see that we have a pin for Koki Games. Let's go ahead and do that for the other two. As you can see, we now have 3 different pins for each individual item in our array: Koki Games, Unreal Engine, Epic Games, and Default. Default simply will fire if nothing else is applicable, then a default pin will fire. You can add as many pins as you want, but in this case, we'll again keep it simple and use a print string to notify us when a selection was made. So go ahead and add a print string. And for this one, let's just simply say Koki Games and connect it to the right pin. Let's do the same thing for the other 2 pins. And now let's add one last one to default. And in this case, let's simply add item not found. Let's go ahead and compile and see what's going to happen here. Every time we begin play, we will simply grab a random item from our array, and our switch statement will execute a different action based on the random item that was selected. Because random will always pick an item that is found in the array, we should never see the default pin execute, because these options will always execute, at least one of them. But in the case when we don't have random and we have another entry, there is a possibility that we may not have the option, and in that case we would fire the default none. So let's go back to our map and test this out. Click on simulate, and in this case we see Koki Games. Let's try again, and we have Koki Games again. In this case we have Unreal Engine, and in this case we have Epic Games. Let's go back to our blueprint. As you can see, we are executing different coding paths based on our selection. You can have switch statements for almost any kind of variable, floats, integers, strings, etc. And this is a very useful node every time you want to have a different code execute based on your selection. Let's do a quick recap. We learned about the sequence node and how it executes code sequentially. We learned about the flip-flop node and how it alternates between two execution paths indefinitely. We learned about the do once node, which executes code once and can be reset. We looked at the do n node, which executes code n number of times and can also be reset. We learned about the branch node and how it executes one of two execution paths based on a resulting condition, which is a Boolean. We learned about the for each loop, which loops through all elements in an array. We also learned about the for loop, which loops through a first and last index. And we also learned about the while loop, which loops indefinitely until a condition is false. And finally, we looked at the switch statement, which chooses an execution path based on the selection. If you want to practice what we learned, look at this table and think of any other examples where each node would be useful. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.